Okay, hello everyone. Am I audible now? Hello.
Yes, we can hear
Yeah.
you.
Thank you. So, my name is Sudhakar. I will be dealing with the module Basic Data Understanding. And with me joining Rishabh and Sahar, they have prepared in they are preparing the assignment module and all the modules for this course. Definitely, Rishabh and Sahar will join us for discussing the tutorial of this course, which is scheduled for tomorrow. So in this today's lecture, we will cover these things basically: goals of data science, data types, mean, median, mode, and types of plots, distributions. So without making any delay, I will just walk you through what are the goals of data science and how it is different from that of a data analyst. So means as we all know that means data analysts, they basically deal with uh, EDA, which is exploratory data analysis, and the role of data scientists is to find the pattern in that data. Means the data scientists also they perform EDA, but then they have to find the pattern so that the model can be deployed, and further we can use that model to predict certain things. So as I have mentioned that predictive analysis, prescriptive, these things. So data scientist or the role of data science is to cover these things basically. So then as we can
Sudhakar,
see
can I?
that there are mainly six.
Hello, Sudhakar.
Yes, sir.
Some people are saying the audio is not clear.
Yes,
Are
sir.
you close enough?
Yes, sir. I am close enough.
Okay,
Okay.
all right.
Is it
Okay,
better or?
it's fine. Yeah, let's continue.
Okay, thank you. So these are some of the steps which are involved in the data science. As you can see that discovery means like finding the details of the project, like what should be the input, resources, output, all these things. Then preparation, model planning, build. So all these things you can follow this reference to go all these things in detail. And yeah, so we will see some of the things which was covered in the first session just to give you a warm up, and then we will begin with the main agenda of this particular lecture. So I will just switch on to Google Colab now. So I will upload some of the data sets to begin with. And yeah, so yeah, so we will just load all these libraries. All these things have been discussed earlier, so I will not go through all these things. So once it is run, then we will begin with the next code snippet. Okay, so we will discuss about how to plot a basic sine plot, and then how to means plot another cost on the same plot. Okay, there is some issue there. Just give me a second. Okay, I think there is some problem with my internet. Is Rishabh here? Rishabh, are you here?
Yeah, I am.
Okay, Rishabh. So can you please continue? I will join you in a bit. I think there is some problem with my internet. So can you please? I will stop sharing my screen, and then
Okay,
can you please share
okay,
your screen and begin?
okay, fine.
Yeah. Okay. Okay.
Hello. Hello, am I audible?
Yes.
Okay, so it seems like Sudhakar is having some connectivity issue. So let me resume. Mm, okay, so let us start from. Is everyone able to hear me? Mm,
Yes, we can hear you.
yeah. So first of all, we will be importing some libraries as Ipsit has discussed in previous module. So Panda is for working with data frames, and NumPy is basically for dealing with different mathematical operations. Seaborn and these modules are just for plotting graphs. It will be helpful in that. So if we if we want to, for example, here we are assigning a variable, we are defining a x variable named as x, and with a range of minus pi to pi. And here the point one is the increment, is showing the increment while going from this range to this range. And why we have assigned the value of sine x. So here the x is the whole list of this value. So if we plot this, we can see. Okay, so I have not run it yet. So let me run this first.
Yeah, Rishabh, meanwhile, can you please close this upload window, the cross in the right, top right, the cross symbol, files upload refresh. So you can close that uploading tab. Yeah.
Okay.
Yeah, this cross one. Yeah, this thing.
Okay, fine.
Yeah. Hmm.
So now I have uploaded all the libraries. Now I will start plotting this graph. So this is the graph we have plotted of sin x from the range minus pi to pi. Now if we want to include cos x graph on this plot only, then let me then we can plot the on for plotting this graph on the same plot. We can give a input variable x and the y as a np dot cos x. Here the x is the same as we defined here. This is minus pi to pi with an increment of zero point 0.1. And the legend will tell us the graph, a kind of what graph is representing which curve. So on running this, we can have a look. Huh. So this is the dotted line is shown as a sin x from minus pi to pi, and the orange line is the graph of cos x. So now switching
Yeah,
on.
Rishabh, just a minute. Can you please scroll up? Yeah, so as you can explain about this XYO, PLT, the third line, PLT dot plot XYO. So
Yeah,
everyone,
so
please.
O is
Yeah.
the type of graph that you want to plot. Here we are plotting, for example, here we have put O value. That means that we are plotting the points, exact points. And here we didn't put that, so by default it is plotting a smooth curve. We can try different values such as geo, bo, or various other things that you can look at the documentation part. They have other data, other input value for this section as well. So it would be helpful from that part. Now if we switch on to plotting the line plots, so here I have defined three list variable x, y, and z. Now if I plot x, plt dot plot xy, then it will show something like this. Now if we want to plot same xz, then on the same graph it will plot the value of x and the z's. Here I have entered the same value of x for both the graph, and the y and z are different. Now for aesthetics part of this graph, we will label the axes and the title of this graph, and we will also include that which curve is representing which value. So let me try this.
So
Yeah.
yeah, so people are asking that what is the use of legend. So as you can see that now, since we have two different plots and one is of another color, means we have two different colors. So just to differentiate between which plot refers to which, we add a legend. So that's why we have mentioned that this is y, this is z. You can also choose names as per your convenience. So that is the purpose of legend.
Yeah. So that is just to denote which curve is denoting what kind of data.
Yeah.
Now switching on to visualizing the data by loading data frame. So data frame, now let me introduce some slide stuff. So data there are two types of data: quantitative and qualitative data. Quantitative data are those which have a numerical values, and qualitative data are non-numerical values. So in quantitative data, we can further divide into continuous and discrete one. There are different method to visualize these data, and for continuous part, we can use histogram, scatter plot. We will come into these in detail in our collab notebook.
Yeah,
And
so yeah,
yeah,
just yeah, sorry for interrupting. So means continuous means the numerical values like temperature, weight, all these things, and qualitative means like suppose we are grading someone or we are adding something like good, bad, better, something like this. Then that becomes qualitative, or otherwise the numerical values are called quantitative. So depending on what is the type of data, we can choose which plot to plot when. That is the
yeah,
main purpose. Yeah.
yeah. So depending upon the data, we will decide which plot to make to visualize it better. Now here I have. Hope you guys are aware how to upload data in the collab if it has taken that session. So here I am reading the sample data CSV file by using pandas module by function of pd.read CSV. So let me run that first. Now to visualize, since this data is very small, so I can just simply run this to visualize whole data set. We will work with a larger one in upcoming cells. So sample data here is a kind of data frame. So data frame is basically a two-dimensional tabular structure in which we can store different data types features. For example, it there might be some string values in column A might contain some string values, and there might be some categorical variables that we will look into when we will deal with a bigger data set. So the type sample data on running that, it will tell that this is how we can know the type of a particular variable in Python. So here it is showing a data frame type, which is here we have included the pandas using the pandas library pd.read csv. So now this is the sample data dot column C. So column C is one of the column of this data frame, and we also we can call it a feature. And this column is a kind of if when we are writing this, then it means that we are trying to access that column of this particular data frame. So that type is series, known as series. And if we want to extract the first element of that particular column of the data frame, here our data frame is sample data, so we can use the ilog function. If we put 0, then it will show the first one, that is here 10. If we input something like 4, then it will give 2 value. Column C, the fifth row, as it is starting from the indexing starts from 0. Now we will try to plot the values of of these columns. For example, the sample data dot column A. Here we are trying to plot sample data, the column A of the sample data, that is our data frame. And by using this dot column A, we are referring to the column of that particular data frame. So this is will be represented on our x-axis, and this will be represented on our y-axis. Here O again, as we saw earlier, that it is showing to point to plot the data on the point wise basis, and this is to plot data between column A versus column C, and it would be a smooth line, continuous line. So we can run this. Now we have not added any title or something. We have not represented what is which curve is showing which one. So if we use this command, okay, let me see. Okay, we need to comment this out. So here we can see that these dotted representation are the column V, column B data set, where the x-axis is representing column A, and column C is represented by this orange line.
So, Rishabh, let's pause for some questions.
Yeah, sure.
Questions so far? So one question is how color came for the graph.
So color is usually it is assigned by default. You can of course you can change the color by looking at the documentation part of plt.plot. I think we have shared the documentation of matplotlib. You can look at that.
How is Seaborn different from Matplotlib?
So
Yeah, yeah, please
yeah,
go ahead.
Sudhakar, go.
Okay, okay, fine. So yeah, means we also need to explore a lot of things are there, but for some particular plots like box plot, so SNS is very convenient in plotting a box plot or heat map. So heat map is usually plotted using SNS, means Seaborn. So some are the features which are exclusively in Seaborn library only. But for plotting, definitely Matplotlib is a very good package.
Yeah, for some plotting, I think Cbond would be helpful and convenient, but we will use accordingly. So,
Yeah, Rishabh, just a second. So people are asking about qualitative data. So as we
Okay.
have mentioned that the type of categorical data is, sorry, categorical, not qualitative data. So we have mentioned that it is like, okay, yeah, categorical, binary and ordinal. So people are asking about what are the examples of these. So means binary means simple zero one, like yes, no type, married, yes, no. Categorical means like you can have some type of labels, maybe three or four different levels. Okay. Ordinal means the data which has a particular order, and order like 1 2 3. Here 3 denotes that it's a means of higher significance. Like if you label like poor 0, good 1, better 2, so 0 1 2, it has become an ordinal data set. Yeah, Rishabh, you can add if you want something to
yeah,
add.
so basically, categorical data are data which have cardinality almost less than 5, you can say. So, cardinality is the number of unique values of that feature. And there is another one more data type, with one more data kind which is known as nominal variable, which in those are those categorical variable which we don't have any, which we can't be ordered. For example, name of a person, there are three names, so we can't order those variable, right? So yeah, those are the example of qualitative data.
So one question is what is box plot you used for? Are you covering in this
Yeah,
lecture?
yeah, yeah.
Lecture?
In upcoming some cells,
Okay.
we will
All
cover
right.
that.
And then
When we are dealing with, when
right.
we will deal with a larger data set, we will cover that.
Okay. And then in Monday we will cover different types of plots again and in more detail.
Yes, sir. We will also means explain how to customize them. Means yeah, how to add font size, consistency, all these things we'll definitely explain.
Right.
Yes, sir.
So should I go move ahead?
There are two more questions.
Okay, fine.
Yeah.
Pratigya.
Sir, I wanted to ask that in assignment there was a question of superimposing the sine wave along with its spectrum. So in that case, the x-axis is not the same for sine axis and its spectrum. So how to handle that? And we have to superimpose those graphs.
Right. So that was basically just a practice question. You are right. They are the scales are not the same.
Yes.
Uh, so in actuality, you would ever you would not really do that. You would only put things that are on the same scale that are comparable in some sense.
Okay. Okay. So is there an option where the axis on left hand side and axis on the right hand side with a common x-axis can be plotted?
Sudhakar, you want to take that?
So this question is about assignment one, or
Yeah, assignment one.
okay? I am sorry I could not go about the assignment one in detail. So
Okay.
allow us
We
some
might
time.
take this on campus where if
Yeah, let's do that.
Sure.
I think Ipsit will be able to answer what
yeah,
he meant by that.
let's take
Okay.
it on campus where.
Yeah. Okay, sir. Thank you. Yeah.
Rafi Sheikh.
So under which type data using pie chart will fall?
Sorry, can you repeat?
Under which type will data represented using pie chart fall?
So I think we are coming to that, right?
Yeah, we will covering every like whatever the famous data visualization part, pie chart,
Yes,
bar plot,
yes.
everything.
Yeah, to name a few, that we will be plotting histograms, bar plot, pie chart, box plot, scatter plot.
Scatter
So
plot, yeah.
questions on these plots we can discuss over there once we
Yeah.
come to that.
Sure.
Okay, sir. Thank you.
Neeraj Kumar, did you have a question?
Yeah, so I was just confused in that qualitative and quantitative. So inside like qualitative, we have again nominal and ordinal, and again binary data. So I mean, like, is it like how like ordinal and nominal we say? So nominal is the binary one, or because ordinal is like natural order we follow, like high, medium, low, this kind of, and
Yeah.
nominal is like not the natural order. That's what is there. So binary comes in nominal, or which one comes in nominal?
So binary, we tend to think of it as nominal or as categorical, where you have only two categories. We don't think of it as ordinal. So let's say you are classifying between cats and dogs, right? That's binary classification. But does cat come before dog or the dog come before cat?
There
That
is
is,
no natural order. Yeah.
there's no
Okay.
natural order.
Yeah.
Yeah.
Got it. Yeah.
Okay, let's move ahead.
Yeah. So now we will be dealing a bit bigger data set. Here I am loading countries.csv data. And now I am naming the data frame as data. So again, I am using pd.read csv file. It would be really helpful. And now I have loaded these two. Hmm. pd.set options, for example, if our data frame
No,
is
no, just
containing.
yeah.
Okay, sure.
Okay, Rishabh, we can just uncomment it first. Run
Yeah.
data only, then we will show it what that
Sure.
does.
So here, since we have a lot of rows, so we can see that automatically the data frame that is printed here, they have trimmed some of the rows.
Yes. Hmm.
So if we don't want that, and there might be a case that here we have a limited number of columns, but there might be a case, suppose we have a 50 columns or something like that, then it might not be possible to represent whole data set. So it will just trim down and show something like this. But if we want hard code it to display the whole rows or whole columns, every features of the column, then we can use this command pd.set option. Here the none will say that none will give a command that to show every row and every column, and we can enter suppose 10, 20 if we want to see 10 rows or 10 columns, something like that. So now if we run again, then you will be able to see whole data set. And since we have only 3 columns, so it will not matter if we use this or not. So this is our data set right now that we have assigned to data frame variable. Okay. Now move ahead. Now we will compare the population growth in US and China. So this is the data set where the this row is this column name is country, this is population, and I guess this is a year, and this is indexing given by pandas. So this data dot country double equals United States. Basically, what this function is doing is it is slicing out those rows in which first of all data dot country we are trying to access a column of this data frame where with a named country, and data dot country double equals United States means they are trying to slicing out those part of data frame which have in which the country column have United States as as a variable. So if we print this, this will list down all the rows which have United States as an entry in column country column. Sorry. So now we want to store this whole data frame into a new data frame. So here we don't have to explicitly define that US is a data frame. We can, since this is the advantage of using Python, and we can directly assign US as this data frame, which will be the same one as we have printed above. Now, in the same manner, if we want to slice out China entries, I mean those rows which have the country column entry as China, we can assign it to China. Now, let me run these two. Okay, so we have created US data frame, we have created China data frame. We can print down China data. So China here is a data frame, both US and China. Now we will try to plot the population versus year, like how what is the variation of population over the year. So let me first plot the US population.
Okay, can you please comment this second, because the both are the same thing. Okay, yeah, comment this one. Yeah, now run.
You're fine.
Yeah, okay, so I will explain it a bit. Like
Sure.
since the population are in millions, okay. So as you, all of you can see that on y-axis it is showing that 1E8 means it's more than millions. So that's why to have a good representation, we can normalize or we can scale down our population. That's why we are dividing population by a million. Rishabh, can you?
Yeah, sure.
Yeah, now you can comment the first one, the population, and then yeah, comment the first one.
Yeah,
Okay,
I
yeah,
can
yeah,
comment this
yeah.
one, and
Now run this.
just for a better
Yes.
visualization we
So
can
now
do
you
this.
can see that it means that 300 million on the top. You can see that. So we have just scaled down, nothing else.
So now if we want to look at the China population growth,
Yeah. So as to compare the population of US and China on a single plot. So then we will means run these commands.
so here again the plot dot x label will label the x-axis. This will label the y-axis. Plot dot legend, as somebody asked earlier, this will show the. This will tell which curve is denoting which data, and we can run this now. So basically, this orange line is showing the China population in millions, as we have divided it by 10 raised to power 6, and this blue line is representing US population. Now US dot population, as I told earlier, we are trying to assess the.
Yeah. So we can find a conclusion.
Yeah, so we are trying to assess that column of US data frame. So these are the values of population, and this obvious, of course, this is for a particular year, for a corresponding year, 1950, 1960. So we can,
Just one second.
yeah.
Sorry, Rishabh, there are some questions from YouTube. Can
Okay,
we
so
pass a list or tuple in place of string?
Okay, where? I mean, in which place?
Uh, Saqib, what was that question about?
Yeah, I think they mean column selection. Mean for column selection.
Okay, so means okay, so okay, yeah, we can do that. Means suppose a data set have
So
four or five
yeah.
acts, suppose second, third, fourth. So
Okay,
you
Uh,
this
can
is this is
prepare a
the
list
this
of
is what
second.
this is the only thing that they put there. So I don't know
okay.
what they exactly what were they exactly asking for. But
All right.
yeah,
So let's
thank you.
take one or two more questions. Kasina.
Yeah, sure.
Yes, sir. So here to the legend, the X label, Y label, we're
Yeah.
doing all those separately, right? Can't we don't we have any function where we can do all at once, like include those features also inside plt.plot, something like that?
So like you want to write this in a single line, right?
Yes.
So you can look into the documentation part. Like this is a easier way to understand. For more for concise coding, you can look into the documentation. I think there will be some method for sure.
Yeah, here we have tried to means just show you what goes in, so that just you can remember all the functions, or you can know like which parameter to tweak when. Of course, we can have a better way to do this.
There is one question. Can we make the x-axis and y-axis start from 0, 0?
I think there is a function plot.x limit that assign the range of x-axis and y-axis.
Right.
You can try that.
So everyone, please
Yes, that
look
we
at
can
the
do also.
documentation.
While
That will help you discover more things also.
Yeah, because documentation have a lot of function. It is not possible to remember each and everything. So it would be helpful. Sir, do we have more questions? Uh, hello. Uh, hello. Am I audible?
Yes.
Do we have more questions?
I think we can move forward.
Okay, fine.
Excuse me. I raised my hand, but it seems no one's heard.
Okay, fine.
So, I wanted to ask, where can I find this countries.csv file?
Okay, so I have uploaded this file. Like we will share the file as well. So I have uploaded this file in the Colab. While these are just normal CSV file, you can work with any data.
Yes, yes. Thank you.
So I have uploaded it before I started. Yeah. So
Yash, you have a question? Sorry.
yeah.
Go ahead. Yash.
I just asked it. So, yeah, done. Thank you.
Okay, go ahead, please.
Yeah. So as I told, US dot population, we are trying to access those columns of US data frame. So it will print the whole column of that data frame named as population. Now, if we want to divide the whole column with the first entry, so we are accessing that by using this function ilog function 0. So basically, this is the percentage of the population with respect to the first data entry. That is something which year 1952, I guess. Huh. So so the percentage of population with respect to year of 1952, if we want to do that, then we can execute this command. So it will So it will apply this whole function to the whole column, not only one entry but the whole column, and it will divide you with the first data entry, and we are accessing using ilug 0. Now we want
Yeah, means here we are trying to see.
yeah, sure.
Yeah, here we are trying to see like how the population has progressed with respect to the first year. So that's why we are dividing it by the first one so that to have a scaling point or how much times.
Yeah. So we will be looking at the what is the percentage growth from the first year, and for that, as you have seen here, we are putting the year in the on x-axis we are putting year, and on the y-axis we are putting this same function as it is giving the percentage change with respect to year of 1952. And again, these are the legends for denoting curve, and this is the x level and y level. So on running this, we can get something like that. Okay, so now let's move on to some other data set. Here it is movies data. It's again a CSV format file, and we are again using pd.read CSV. Again, we just want, since it's a bigger data set, so we just want to show every row and every column. So we are using these two function as well. So as you might be aware of that, movies.head will show you first 5 entry of the row. Here it is showing 0 because this is panda's index. Unnamed 0 is like panda usually assign a name of the column because it is not mentioned in the our original raw file, that is movies.csv, moviesdata.csv.
Yeah, so means while evaluation we can drop this unnamed if we need, we can drop this if needed.
Yeah, later because it does not have a significant. So movies.shape will tell you the number of rows and columns of this data set.
Yeah, so means we are having observations, means we are having 31 observations for 600 movies. Like name, can you please scroll up, Rishabh? Yeah, so as we can see the title type, genre, runtime, IMDb rating, all these things in 31 features are there for each and every movie. So we
Yeah.
will explore this data set in a bit.
Hmm. So basically every column is representing a particular feature, and as we have discussed earlier, you can when we upload this file you can figure out which one is categorical variable and which is continuous one. So now we will look into movies.runtime. Again, I am trying to access that column named as run type. So let us see. So this is the run type column, 80, 101, 84. These are the entries. So basically, they have a lot of different values. So we can consider it as a category, continuous variable. And as we discussed earlier, we can use histogram. So let me switch to slides once. So basically histogram is used for a continuous variable. It is useful to get a sense of what is the distribution of our data, and there is a term known as bin. So number of bin is the width of this bar that you can see here. And note what is the difference between the histogram and a bar chart.
Interval on the x-axis. This is the number of intervals on the x-axis.
So we can adjust the number of bins according to the data set, and the difference between the bar graph and a histogram is that there is no gap between these bars. And we will look into how to adjust the bin size. So now I am going to plot these data. So fortunately enough that matplotlib has some functions that can plot just these are like pre-written function. We just need to call these functions out, and it will print it will plot the histogram for this particular column runtime. Since it is a continuous, we are choosing histogram. So here it is. We can see here you can see there is a very you can consider this entry as an outlier. So we will look into what is the outlier and all in coming.
Yeah, Rishabh, can you please scroll up a bit? Scroll up.
Yeah, sure.
Yeah, so as you can see that after he ran the command runtime, there was some warning like runtime warning invalid value, as you can see where cursor is pointed as of now, invalid value encountered. So it means that there is some missing value in this column, means runtime had some missing value. So that's why in the next coming steps, we will try to find out whether there is a missing value in the runtime.
Yeah.
Yeah, you can proceed, Rishabh.
So we just want to describe. So describe is basically will give all the statistical information about this column, this feature, runtime feature. So here it is showing count 599. However, when we have loaded the data, it is showing 600. So it is showing that there is something missing here.
Yeah, means one value is missing, one row has not having their
So
runtime.
using this is in a function, dot sum will tell how many entries of that particular column are messed up. So here we will just drop those columns to ensure that our data set is proper and clean. So let me movies dot drop in a, basically it will drop every rows in which any one of the data are missing. So here we can see there were 28 rows where the which have at least one of the column in which there are no data. So we have just removed all those rows. So now we would find that there would not be any rows with missing data. Here it's coming 0.
Yeah, and yeah, I would like to add one more thing that while dropping, as you can see that we have 28 rows which were having some of their columns missing. So we, like it has been written also as a comment that we can also impute the values, and this we will cover in the assignment. This has been given as a task, so there you will learn how to impute the values.
So basically, imputation means how to deal with those missing value. Either we can use the mean instead of that missing value. We can just assign the mean value, or something like that. You can have a look on the assignment when we'll upload.
So
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 how
let's
will
let's pause for some questions.
yeah, sure.
so how will
Ryan, followed by Kasina. Ryan Ahmad. We cannot hear you, Ryan Ahmad. So maybe you can type your question, Ashish.
Yes, my question is, we didn't mention the bin size, right? When we called the histogram function.
We will look into
No,
that.
no, like in the upper plot, not in this one. Upper plot, like
That is the by default according to the data. It
that's
will.
what I'm asking. If I just check the documentation of matplotlib, the default bin, like there's a command called bins, right? And it's none over there. So I'm really interested in understanding what in journal this, the what is the default bin size that is taken, because it changes from data to data, right? And I think it is adaptive in nature. It's not like when we don't use that argument.
I think
So
it gives you 10 bins by default, right?
it says none. Yeah, I just checked the documentation. Like the default value is none for bins.
Okay, we'll check it and explain in campus wire. Neeraj,
Yeah, so while dropping the nulls, how we'll get to know that, I mean, for some nulls we have to drop, or for some nulls we have to impute the value? I mean, on what basis we do that? Is it like more than 50% of data is null in that particular column, then we will drop that column? Or, I mean, on what basis we do that?
Yeah, so you have raised a good point. If the particular column has 50% of data missed out, then I think it would be beneficial to drop that column out because that would not be helpful. Or that imputation part here we are just dropping, but you can try the other methods such as assigning mean value or something like assigning the same value of that column of the just above box.
Whoever has asked the question, they can mute themselves. Amlan, is your question done? Ryan Ahmed? So Ryan had a question. I think his question was, what is 25%, 50%, etc. under describe?
Okay, these are the quartile range. We will cover it in when we are discussing box plot. We will be covering it in some time.
Another question, are these modifications on the data frame are in place or returns a new data frame?
So, for example, these are in place because as you can see, we have here we have assigned that function. So I guess we have to store it on the same name. For example, here we are dropping, and after that we have assigned it again to the movie. So yeah, we need to define another variable for that. We can reassign to the same data frame. Do we have more questions, sir?
No, let's move.
Okay, so here we have shown a customized version of histogram, how to plot a customized histogram, where you can vary all the color, orientation, and the bin size. And I'm pretty sure there are other features as well. You can look into the documentation part again. And this is the same title and the X label. Here, as somebody asked earlier, how to fix the range of X axis and Y axis. You can do like this, and it will plot this graph. Now again we are just printing out the first 5 rows of movies. Here just note that here we have removed all those entries where which have any one of the column as a null value. Now we will be plotting pie charts. So this movies dot genre, we are again accessing those columns named as genre, values of those columns, and value count will give the unique number of unique values in that column. For example, when we run this, it will show that in this genre column, you have these seven different, the cardinality is 7 first of all, and these are the different values, and the count of the drama is 298, comedy 86. So it will give the number of unique values in that particular column. Now we will plot pie chart for this, and this is the pie chart, and if we want to include labels, then we can do like this. Here it is.
You can comment the second line. You should comment the second line.
Okay, fine.
Yeah.
Yeah, so second line was giving the value, was plotting these value as well. So
Yes.
it was messing up. Yeah, so it would be a nice representation. So you can see that since it is a categorical variable, it is like we can see it. uh, just now we will move ahead. Again we are printing just first 5 rows. Now movie sub. So here we are slicing the first 10 rows, and movie sub dot. So movie sub again is a data frame. We don't have to define it explicitly. And movie sub dot shape is will tell us the number of rows and column in movie sub data frame. So on running this, it will give like
Yeah, so actually we are here going to plot a bar chart which will have movies name on the x-axis and its IMDb rating on the y-axis. So here we are having more than 500 movies. That's why we have created a small subset of 10 movies only, and we will plot the IMDb of those movies.
yeah. So this movie sub is the newly defined data frame that we have defined here, and plot dot bar will create a bar chart. Note it is different from histogram that we have plotted earlier. You can see the difference. There is a gap between the bars. Again, this is our x-axis. This will be our y-axis. These are for x levels and y levels. And on running this, we will get this bar. But you can see that these labels are get cluttered. So I will just comment it out. And if we rotate the whole x-axis level by a 90-degree, just to ensure that it looks good, so we will see that it is looking much better. So in this way we can customize our plots. So now we will look into heat maps. Just a minute. So first of all, I want to go through this slides. So what are the mean, median, and mode? So these are the statistical data that will help us to measure the central tendency of a given data set. For example, mean is just the average. Median, we can, I think you guys must be aware, we have uploaded pre-read material for these. And median is, for median, we need to arrange our data, and the middle value would be the median value. And mode is the one which has the highest frequency in that data set. So there is not a well defined algorithm when to use mean, median, mode, but surely we can choose the better one. And there are when to use mean, median, mode. So median is basically preferred when our data is skewed. For example, a skewed data, I think we have not included slide here. So basically a skewed data have mm, just a minute. Mhm. So skewed data is when most of our data points lies not at the mean value, but either to the left or the right. So at that point, we will try to use median over the mean, because mean will not give the central values. In case of normal distribution, when data is perfectly normal, then all the mean, median, and modes will be the same value. We will look into the distributions later. Now, order statistics are those, for example, mean, and mean is an order statistic because mean is not an order statistic. Median is one of them because we need to arrange the data set, but arrange the data set for finding median. But for mean and the mode, we don't need that, so they are not order statistics.
Yeah, means whatever values we first put it in an order, and then the values which are found out from that ordering, that is called the statistics.
Yeah. So box plot, when I will.
We pause for a bit.
Yeah, sure.
Okay, so one question is please share the PowerPoint also. So I guess we can do that.
Yeah, sure.
And then Rafi, do you have a
Yes, sir.
question? Rafi Sheikh?
So in case of pie chart, how will we represent the percentage of each data?
So, well, I'm not aware of that
So
code, but
adding those legends, etc., we'll cover that on Monday. So right now we are
okay.
covering the basics.
Or you can look into the documentation part. These are like there must be some code for that, and you can easily find on the documentation, I guess.
Okay, sir. Thank you.
Prasoon?
Hello, sir. I want to ask you, how do we remove a particular number of rows from a certain point, like from the first 10 rows or from the middle 10 rows, something like that? Is that possible?
Like you want to slice row 10.
Yeah, yeah.
Yeah,
I
so
want to
there we can
remove.
change this value from 10 to 20. If we write 10 to 20, then it will slice out row number 10 to 20.
Okay, okay. So zero is the starting range, 10 is the
Yeah,
ending
so
range. But
no, 10 is not ending in 10. 0 to 10 is not included. It's
okay,
excluded.
okay, okay. So no, no.
Yeah,
This
it's
will give
0 to
me the
9
base.
only.
So yeah, so it is accessing the pandas index 0 to 9.
Uh,
So this will be the pandas index.
No, I am asking how what should be the command when I want to remove those 10 rows. Not means I want to remove out of those 600. I want to remove the top 10 rows.
So
So
you
is
can
there
slice
any?
out the remaining 590 rows. You can add the 10 to 600, something like that.
Okay, okay.
Like that don't matter. Either you remove or slice that out.
So Pragya has a question. What is skewness? Can you explain skewness again? So imagine a Gaussian curve, right? So Gaussian curve is roughly equally distributed on both sides of the mode. Skew, if you have a skew, then it will not be equally distributed on both sides of the mode. So that is how you can think about skewness. Sumit, do you have a question?
Yes, sir. So this is regarding the pie plot. Can we go to? Uh, yeah. So in the code there are two plot.py. So I just want to know what two plots are doing.
Sorry. Can you repeat?
So in this code, the first is plot.py genre counts, and then again you are doing plot.py. So twice we are plotting the
So
pie.
no, it's not about plotting. It's like as somebody asked earlier also, we can I think we can comment this out.
Okay, so is it overlapping? Oh, okay,
Yeah.
okay. So the two plots were, I think,
Uh,
overlapping each other. Okay, thank you.
Yes, yes.
So these are just for aesthetics part. You can look into the documentation. Like there are a lot of things you can say percentage. You can have a tabular representation of these labels, something like that. You can have a look on documentation.
Vanshita?
So am I audible?
Yeah.
Yes.
So can you please explain the label part in the pie chart, that tool list one?
Mm,
Yeah, okay. Yeah, Rishabh. Okay,
yeah.
can you
Go ahead.
please go to yeah, okay. Yeah, so here, can you please scroll up? Yeah, up. Yeah, so see, first of all, we try to find out the value of each unique values like drama 298, comedy 86, and all. So then it's like genre counts, the value counts, it gave us a series.
Okay.
So that's why in order to use it as a label, we had to use it as a to list. Okay, that's why you can see that we have passed dot index dot to list. There are other ways also, but this one we have applied. So it was just to convert the series into a list.
Okay. Thank you.
Yeah.
Yeah, yeah.
Yashasvi?
Okay, my doubt was, can we use X sticks for pie charts as well?
Sorry, can you repeat?
The X sticks which we used in the bar graphs.
I
X
can't.
takes. We will have to check. Yeah,
I
Rishabh,
can't
if you
hear
could
actually
add.
properly.
Yeah. Okay.
So a couple of questions from the chat. Is series and list different in view of arrangement of data? Okay, Sudhakar already answered. View is the same, but while extracting, it's different. So one question is, if most of the students in the class get greater than 90, in such case, how will median help? Rather, mean would be better, I think. So
Yeah.
that, you have to, uh, so if most of the students got higher than 90, then uh, I mean, depends on what your purpose is, right? If you want to see uh, at what point half the people are above this and half the people are below this, then median is the best way. So there is when you are computing mean, usually there's an assumption that it is Gaussian distributed, and then the distribution is symmetric on both sides of the mean. So if that is not true, then medians are usually better to understand where the midpoint of the data is in some sense. Tanish,
Yes, sir. In the data movie data frame, there is a column named unnamed 0. So how
Yeah.
can we rename that?
Okay, so you can simply pass it like you can call it movie dot unnamed, that should be equal to movie, and you can pass it a different name.
Okay, sir.
okay, let's move.
कुछ समझ में नहीं आया उनको उनको कुछ समझ में नहीं आया वो थोड़ा कंफ्यूज हो गए
Okay, so now we will look into heat maps.
Yeah,
So
so
yeah, Sudhakar, go.
okay, so means basically heat map is used to find, like here we are using it to find the relation between the variables. Okay, so that's why we are first defining a figure size. Okay, just to have a wider view or shorter view depending on our need, and then we have created sns dot heat map movies dot core. So basically core function will find out all the means relation correlation between all the numerical variables. Okay, so yeah, please run this code snippet, Rishabh.
Yeah.
Yeah, so as you can see that it has means both the variables on the x-axis and the y-axis as well, and there is a stick, the vertical one showing 1.0 to 0.8. That is basically showing like what is the relational value. So we know that correlation can exist from -1 to +1. Minus means negative value shows negative relation, means one variable goes up, another goes down. Similarly, positive means both goes up at the same time. So that is just to showing. Now we can add some parameters to make this look better. The heat map, we can make it better. Suppose you can add these parameters, Rishabh.
Yeah.
Yeah, you can uncomment that. You need to add this also. No, that will not help. That will not help. You have to just uncomment it and then insert inside the comma. Okay, that will,
What is
no,
this?
no, no. Just movies.core parenthesis followed by comma.
Yeah. So these are basically to improve the aesthetics for this heat map. You can use these two functions, and basically we are anyways getting the heat map from this. This is our main code, and basically if for example these value are representing a highly correlation just because these two are the same variable. So if the value is closer to one, those two variables are highly correlated. Once we get we can also visualize the correlation between two variables by plotting scatter plots between those two. And for example, if there are a variable which is highly correlated, and if we plot scatter plot for those two, then those seems to be highly related in the graph itself. So this is all about this heat map, and now we will switch to scatter plot. So now I will be plotting the scatter plot between IMDb rating and audience score. I am using that same movies data frame, and C red is color for the point. Here we are setting the X limit from 0 to 11 because our X value is IMDb rating and it is from 0 to 10. So just for safety, and audience score is between 0 to 100. So I'm setting it to be from 0 to 101. And this is our title. So on plotting this, we get this graph. So here we can say that these variables are highly correlated. Not exactly highly, but they seems to be correlated. And how to deal with the correlate variables which are correlated in the machine learning model, we will cover in upcoming lectures. And we can,
Maybe
yeah.
you can draw another scatter plot, PLT dot scatter. Just below that scatter plot, there is again one more scatter. So you can uncomment it and you can plot it. Yeah, coming that one, yeah. So see, the problem is that we are plotting critic score and audience score, but the limit is not same. That is the main problem, because we have set X limit from 0 to 11, Y from 0 to 100, but critic score is from 0 to 100. So Rishabh, can you please make X limit from 0 to 100?
Yeah, sure.
So now you can see that there is some this audience score.
Sudhakar, your voice is breaking.
Yeah. So here again, you can say there is a correlation between these two variables, these two features, and the best way to have an idea of correlation is to see this heat map and their corresponding values from this using the sticks and colors. So anyway, we will be dealing with how to deal with correlated variables in next some lectures. So now we will see how to plot a box plot. So for that, I will use some lecture slides. So basically, box plot is it helps you to visualize the distribution of data. So first quartile range is every box plot have these 5 lines, right? This is the Q1, that is quartile range 1. Yeah, this is the median or Q2, Q3. This is the high maximum value. This is the minimum value, and these some points are the outliers that I will define in a minute. And so lower quartile, first of all, the difference Q3 between the Q3 and Q1, Q3 minus Q1 is known as interquartile range, and Q1 is the 25% of the data that we can see when we use that describe feature here. So I think I have used it. Yeah. So these 25% of the data, the value comes out to, when we arrange it, and the first 25%, the value comes out to be 93. So this is denoted here by Q1. The median would be Q2, as I described earlier. That is something the middle value. Upper quantile is the 75% of the data. Highest value is calculated by using 1.5 times of interquartile range, and the lowest value is I guess zero point 0.5 of interquartile range. And so this is how we can plot the box plot for every features. Now, so we are for a feature, for example, here we are defining a new feature known as difference. And it is the difference between these two columns. So here we can directly, since the number of rows in both the columns are same, so we can directly take the difference of these two columns and assign it to a new column named as difference. And we are using SNS.boxplot to plot box plot here. And the genre here, data equals to movie. Here in the data we have to input the data frame name, which is movies here, and genre and difference
Yeah, so
are,
basic, so
yeah,
yeah, so basically, could you please pull up?
yeah.
Yeah, so SNS dot box plot, then x-axis, yx, then the data from which this column has to be fetched. So yeah, so this manner we have put it, and the next lines like xt levels, rotation, all these things have been used to customize the plot. Like we have the rotation of 90 means it will rotate the levels. All these things we are doing it. Means there are also other parameters which can be used.
Yeah, you can look into the documentation part if you want a better customization of your own client.
Rishabh, can you explain what Sudhakar said again? Most people couldn't hear it.
Okay, so basically, these genre and difference is the label of x and y axis, and this chart dot set x stick labels. So these are just for customization. These are the different features. So you can. I'm sure that there are other feature as well which we have not included. You can look into the documentation part, and this is just for customization and aesthetics of this plot. And on running this, you will get the box plot. So this is the all the unique value that is coming up in this genre, in this genre column of that data frame named as movies. So we have defined movies data frame earlier, and this difference is the column of the same data frame, and we have used it on our y-axis. And note that these outliers are those numbers which are above the maximum, and here we are defining the maximum by 1.5 times of quartile range. Quartile range is the difference between q3 minus q1, and q3 is this, q1 is this one. So we have already covered scatter plot. Now we will go to, so now we will look into distributions. I think we are going to, we will be uploading some reading material for what exactly a distribution is. Right now, we are more focused on plotting these distributions. So, for example, a Bernoulli distribution, you can consider a Bernoulli distribution as if there are two outputs, and for example, head and tail, and the probability of coming ahead is zero point 0.7, let us say, and tail to be 0.3, then the distribution is said to be as a Bernoulli distribution. And just to plot those distributions, we can again use the same that we have used earlier. We are using bar graph, and we have defined a side 0 1 side is a list that has 0 1. You can consider 0 as an event of getting tail and 1 as a getting head, and zero point 0.7 and 0.3 is again a list. 0.7 is the probability of getting head, and this is probability of getting tail. So 0 is consider 0 to be head, so probability of getting head is 0.7. So now we are plotting the bar. This would be our x-axis 0 1, and this would be our so this would be our y-axis. Okay, fine.
Yeah,
So
maybe you can explain the normal distribution first, and then we can cover the remaining one if time permits. So you can cover the, if you scroll down, you'll find normal distribution
yeah,
and uniform. Yeah, uniform also you can explain. And
uniform also. So a uniform
yeah, uniform.
distribution is when all the events have equal probability of occurring. We will be sharing some reading material for these distribution in detail, but here we are focused on plotting these distributions. So for example, a rolling unbiased dice, we can say the probability of occurring any number from 1 to 6 is 1 by 6. And so here this is like a list having 6 1 by 6 comma 1 by 6 times, and this is side we are defining another list of side 1 to 6, and then we are defining a series data type named as S. This is a title, X level and Y level, as I discussed earlier. So this is the way which you can get this uniform distribution part. This is to assign colors for x-axis and y-axis to set the limit from 0 to 1, because probability can't be greater than 1. And plt.gsa is getting I don't remember the full form of this GCA, but this is how you can get a plot for a uniform distribution, and that's it for uniform distribution, I guess. Now we will look into the Gaussian distribution, as most of the phenomena in nature follow these distributions.
Mm.
And here we are defining np dot arrange -100 to 100, basically list with -100 to 100 with an increment of 1, and we will be using smooth curves to plot it. So normal, as you might have seen that we have imported ma- we have imported this module as well, named as SciPy stats. So you can look into its documentation. Basically it helps in it is useful, apart from plotting only distribution, it is useful in other stuff as well. You can have a look on the documentation part, but here we are using that for plotting our distributions. So here we are defining the normal. So mean would be like 0, as I have a mean is a variable, normal variable. Here we can see that it is a int, but we don't have to define it explicitly, and I am putting that variable into this function stats.norm.pdf, probability distribution function, and this n is the data points on the x-axis. So, and this 20 is the variance. I hope you guys are aware of variance of this data, of a particular data. Variance, no, I guess it's standard deviation. So plot n dot normal, n is our data points and normal is our y-axis values. These are again the customization for x level and the y level labeling, and this is the title. So when we will run, then we can get this distribution.
Let's pause for some questions. Kasina?
Yeah, sure.
Yes, so I had a doubt in box plot.
Okay, fine.
Yeah, so essentially we identify the outliers, correct? Or
And
are
like these are our the range in which most of our lying, and to get a sense that what is the maximum value that could be there. For example, include them from while training a machine learning model.
Not every of those sticks that you see that looks like a box, right? So it kind of gives you a cut of the of a different distribution. You have a distribution in blue, another in orange, another in green, another in red, and so forth. So if you were to otherwise represent distributions, you will have to plot all of them separately. Here we are showing the cuts, which is the median or the mean, which would be the center line, and then the 25th and the 75th percentile, which would be the top and the bottom, or sometimes if you use mean, then you show the first standard deviation. And then the top and the bottom shows you the typical max and min. And then if you still have some outliers, those are the dots. So basically it shows you like the entire distribution in a single plot so that you can compare multiple distributions. This becomes useful when you are trying to see, let's say, you have people who were given a treatment and people who were not given a treatment, and you want to look at their distributions, like how long do they survive? Does treatment really have a difference in outcome? So you would like to see that the box plot of the people who were treated would be slightly shifted up. Even their 25th percentile is above the 75th percentile of those who were not treated, or something like that. So you can easily have a very good visual comparison of different distributions. Yes, so Pragya, the box plot also shows skewness, because you can see that from the center line, if the box is the above portion of the box is more than the lower portion of the box, then it is skewed towards that upper side. So does everyone know Bernoulli distribution, right? So Bernoulli is when you have a binary outcome, right? So that was one of the questions. What is Bernoulli? Okay, so yeah, so that's basically both of these bars will add up to 1. Can you explain the binomial distribution? Can you show the plot? Yeah, so binomial distribution is basically you take multiple of these Bernoulli distributions and you take them together. So let's say if you're tossing a coin, right? So if the coin is biased, then you will get a single toss will give you Bernoulli distribution. But if you want to look at the number of heads, the distribution of that, if you toss it multiple times, then you will get a binomial distribution. Different colors are different items. Yes. So different colors are basically different distributions. So you're comparing different samples. One sample is in one box plot. The next box plot shows you the next sample, and you're comparing the mean, median. Sorry, you are comparing the median 25th percentile, 75th percentile of different distributions. So the first distribution of drama, second distribution of comedy, third distribution of is of horror, and so forth. GCA is get current access. So basically you can get the access handle, then you can manipulate that.
Yeah, so geez.
So Prabal, binomial is basically many Bernoullis put together in some sense. So one toss of a coin is Bernoulli. And if you have n tosses, then it becomes binomial. Mask is used in box plot. Rishabh, you want to take that?
So sorry, what is the question?
Why mask is used in box plot?
Mask.
So if you could show the heat map once. Heat map.
Yeah.
Yeah. So miss, see, yeah. Please scroll down the map. I want to see the heat map.
Okay. Yeah. Sure.
Yeah. So the diagonal line, which is the white one, the diagonal line showing a white. So it shows that okay. So miss the data below and data above that means those are same actually. Okay. So that's why mask is just used to remove the one side. So that is the idea, to remove the similar type elements to occur in the heat map.
Question, can you show correlation values if features are very high, because it is usually clumsy in correlation matrix, hence not in a position to identify? What do you mean by, oh, the number of features? So in that case, correlation matrix will become quite large. So it's usually quite difficult to look at correlations of several variables. So let's say if you have 100 or 300 variables, then it's difficult to look at correlation matrices. So at that point, sometimes it's better to reorder the variables so that the highly correlated variables form like a block diagonal matrix as opposed to just a diagonal matrix in the correlation. So then you can see these are the groups of variables that are correlated. So those are some more advanced techniques that hopefully you'll pick up throughout the course. Can you draw the distribution based on the box plot? No. So box plot is a summarization of the distribution. You cannot go back to the distribution. It just gives you some idea of the distribution. It's not the complete distribution. Can we get an example where heat plots is generally used? So heat plot, like you mentioned, this is for correlations between variables, right? So there it is quite good to use that. I'll give you another example. So let's say you are looking at uh, uh, different cancer patients and which treatment they were given and what genes they had. So if you want to compare whether certain genes, having certain genes, genomic defects prompt the oncologist to give certain drugs, then you can show that as a heat map. Then you will see that uh, some gene expression is more related to the patient getting a certain treatment and so forth. So is the color of the heat maps indicating correlation. Yes. So heat map means you have a certain color at the range which shows you high value, another color at the opposite end of the range that shows you low value, and then it's a quick visual of where the high values and where the low values are. So for example, if you look at this heat map, the lower right portion, you will see a block, you'll see a square that is lighter than rest of it. So that means this IMDb rating, IMDb num votes, critic score, and audience scores are highly correlated. That's why you see that block diagonal structure at the bottom right. So these four variables are very highly correlated. Other variables are not very correlated except for DVD release year and theater release year, of course, because usually it would be like a few years after the theater release. So those are very correlated. But other than that, the variable is only correlated to itself, which is the main diagonal. Other questions? Okay, let's go.
So we were looking at the Gaussian distribution, and now there are few more distribution such as Poisson distribution and exponential distribution. We are not going into details of these what exactly are they, but this is how you can plot the distribution for Poisson. Here lambda in range 0, 10, comma 2 is like in the range 0 to 10 with an increment of 2. And again, we are using the module stats.poisson PMF for n comma lambda, where n we have described as we have assigned a list of 0 to 49. And so these are the 50 points with an increment of 1. So here we are plotting the number of n is the data points like 0 to 50, and Poisson is this value for so we are calculating Poisson for every for loop, and for every each time we are plotting a graph. So as it's have covered in the previous lecture, here this is just the string formatting, dot format lambda. So these are the X label and the Y label. These are the title, and legend is for showing which plot is represented by which color. Again, so exponential distribution is the formula for it is lambda e ki power minus lambda x, and here we have defined lambda to be 0.5, and again we are taking point 0 to 15 with an increment of very small 0.1, and we are plotting x comma y with the same labeling as dot format lambda, and x label and y label are like we are assigning the font size for x and y axis, and the title as exponential distribution, and after that we can plot it. So I think we are done.
We have covered most of the yeah, all of the things actually.
So that's the end of the module. Questions? So for central value, we are using mean and median, but high order moment may give us exact value for our data. So can we use it? Yes, you can use high order moments also. Here, each distribution is plotted after knowing the distribution type, but how to know which distribution is that data from? So this is a great question. This is basically hypothesis testing and some of those things that they cover this in the sense that so what you would do is you have some data points and then you would compute a data likelihood for a particular distribution and find out whether it is likely to be generated from that distribution. So that's a slightly more advanced statistical. We will cover this in one of the future lectures. Uh, So COVID-19 is exponential distribution. So the rise in the number of cases, or basically the cumulative number of cases in COVID, those are exponential, yes. Because each person infects, let's say, 8 other persons or so forth. So if you take that, it has a multiplicative effect and it becomes an exponential distribution. But obviously, after some point, you run out of people to infect. So it is exponential only in a certain range, and then it starts to flatten out. So if you look at certain graphs of COVID rise in different countries, if you plot them on log scale, you will see linear curves. Is the target variable, should the target variable be considered in the heat map? Not sure what that means. Which target variable?
I think he's talking about why, like target output.
Okay. Please share the slides. Yes, we'll share
Yeah,
the
of
slides.
course.
Yeah. COVID-9 will soon become bell-shaped. Not sure what that means. It depends on if you're talking about new cases or cumulative cases. Can't we say that from the plot, which distribution is that? Yes, by looking at the plot, we get some idea what the distribution is. But obviously, real-world data will not fit exactly onto a theoretical distribution like a gamma distribution or a Gaussian distribution. Would we be dealing with uncertainty in the data too? That question I don't fully understand. Perhaps you can explain. Sir, can we plot CDF of distributions? So I think there is an option to plot CDFs also. Is that correct in SciPy? SciPy stats? There
Yeah,
should
I
be.
guess we can just change this PDF to PDF. Uh, Probability mass function to cumulative distribution function, I guess.
Okay, let's try this.
Yeah, so
So
it
you
is.
can do CDFs also.
Yeah, so we can just look, they
Yeah.
can look at the documentation part for this, I guess.
Is the distribution of independent variable effect on the prediction of the dependent variable? Depends. I mean, it's not always true. There are some independent variables that have no impact on the dependent variable. Do all patterns in nature follow the same distribution? No, not quite, right? So if you look at, so when we are looking at, let's say we are looking at heights of males of a certain race, right? So people say it is a normal distribution, but it is not exactly a normal distribution because let's say the average height is 5 foot 8 inches, whatever that is. The normal distribution goes from negative infinity to plus infinity, but there's a negative height doesn't mean anything, and positive infinity is also impossible. It's physically impossible. So in general, it the heights follow normal only in a very tight range around that mean. Maybe up to let's say 3 standard deviations it follows a normal, but after that it like definitely is not below 0. It's definitely maybe not below 1 foot or something. um, so, 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 real distributions don't, natural distributions or actual random variables don't follow uh, theoretical distributions. Theoretical distributions are only the closest fit that we find in different scenarios. Are correlations and covariance the same? Um so correlation and covariance are closely related, but they are not the same. Please look up the definitions. You'll get an idea. Um, Sir, should the target variable be considered in heat maps? Can you explain this question? Then the one question is, what is CDF? So CDF is cumulative distribution function. So uh, cumulative means that at any point it tells you what percent of the data is below that point. So let's look at that CDF that we have of Gaussian. Can we run that as a CDF?
So this is the PDF, and
So if you take this PDF and let's say if you plot its integral, that would be the CDF. So what that means is at any point. So now if you compare these two plots, right? Uh, the the top one is the integral. Sorry, the bottom one is the integral of the top one, and the top one is the differential of the bottom one. So PDF tells you what is the differential probability at a particular point, whereas cumulative tells you what is the probability of having numbers below that particular point. Is there any function to find moments? Yes, the function to find moments is quite straightforward. It is whatever variable x minus the mu of x to the power whatever moment you are finding. So if the power is 1, then it is mean. If the power is 2, then it is variance. If the power is 3, then it is skew. If the power is 4, it is kurtosis. Can doubts on NumPy be addressed? If so, explain about ndim and how to say which dimension is from a shape of an array. Uh, so do we want to address NumPy issues here, or should we take them to campus wire?
We can take it on campus where I guess.
Right. Okay. Hitesh, you have a question? Hitesh Chopra? Okay. All right. Any other questions? Let's quickly look at YouTube if there are questions there.
Rishabh, there is one slide announcements in the last slide. Can you please show that to the, yeah? And you can make these announcements.
So we will be releasing our assignment just in few hours, and just try to submit it before the next lecture, that is on 19 April. And the tutorial will be held tomorrow on the same 9 p.m. And the next lecture would be on the 19th of April at the same time. So just be aware, like assignment will be released in few hours.
There is one question from YouTube. Y hat for COVID-19 should be proportional to x1 minus x by population. Did you understand the question?
Sorry, sir. Can you please repeat?
So it says y hat for COVID-19 should be proportional to x, and then within bracket 1 minus x by population. Not sure. So, where is the? Do you have a COVID plot?
No, not really.
Okay. So another question, sir. According to original schedule, the lecture was scheduled at on 20th. Is it preponed? It's going to be on Monday, Wednesday, Friday. So if we wrote it as 20th on the schedule, we'll correct it.
Okay, yeah.
So there is a yes, the Rishikesh Kalita. There will be another quiz. That will be the post quiz. That is basically for yourself to see whether how much of the lecture you understood. One request: can you keep the lectures at 10 p.m.? The problem with 10 p.m. is that then it becomes too late. Some lectures become 2 hours, and then that's quite late. So not sure what we can do about that. Perhaps you can bring your dinner to your computer table at 9 o'clock. So when will the post quiz be released? Usually a day after the assignment. So for computing variance, is the denominator 1 by n or 1 by n minus 1? So there are two ways of computing it. One is called biased way, and the other is called unbiased way. So one uses n, the other uses n minus 1. It's you can look it up. It's quite interesting. So n minus 1 is the more acceptable way. So for example, if you have only one data point, there is no variance. So you won't divide it by n. You would want to divide it by n minus 1. Okay. All right. So we'll call it a day then.
Yeah, sure.
Thanks, everyone.